and welcome to this second session of Tips and Tricks in SOLIDWORKS Simulation. My name is Eirin Holmstrøm. I will be your host today. I have a background as a mechanical engineer in product development, and I work as a simulation specialist at PLM Group. I've been using SOLIDWORKS since 2015 and SOLIDWORKS Simulation since 2016. Outside work, I like to keep active, and I live in Kongsberg, Norway. With me today, I have Artyom.
Good morning, everyone. My name is Artyom, and I will be helping Eirin today. So I'm working with SOLIDWORKS since 2014. My main topics are SOLIDWORKS Simulation and 3D Experience now. And I'm a lead application engineer since 2015. And I'm based in Tallinn, Estonia. And if you will have a question during the webinar, please feel free to ask them in the question area. I will try to answer them. And at the end of the webinar, we will have a Q&A session. So, Eirin.
Thank you. Okay, so let's first do a short recap from last time. We looked at some default options, shortcut keys, some other tips to speed up your simulation process, and some tips regarding meshing on how to speed up solver time without compromising on the quality of the results. Today, we'll be looking into how to troubleshoot some common error messages, how to verify and handle stress singularities, and then some nice way to visualize your results. So let's go ahead and start with the troubleshooting. We'll be looking into two types of common error messages that we see a lot in support today. One of them is the mesh creation failed message, and then the different types of messages that can come up when you have unstable models. So we'll start with the mesh error message. To illustrate this, I'm using a very simplified pressure vessel. I have already set up this study so that all my parts are fully defined with the material and everything. I have a fixture and I have pressure on the inside faces of this one. So I'll create a mesh. I'm going to use a standard mesh for this one with an element size of 68 millimeters. When I run this, as expected, I get the mesh creation failed for the following parts, and then I get what parts it failed for. In this case, it's the manhole cover. In this message, I do also get some tips on what I can do. I can try to use different mesh types, such as the curvature-based. We can try to change the global element size by mesh control, and I can also use this mesh failure diagnostic tool to help me troubleshoot this. I'm going to do that here. Just drag it out a bit. So here I get a list with what has failed. I can also show the mesh for those bodies that have been created, and I can show the bodies that have failed to mesh. Often when you get this error message, it is because the element is too big or coarse for some of the components to be applied on. So if I click this one, and then I'm going to create a mesh control for it, which is a common way to resolve it. And I can do that directly from this advisor. And when I have pre-selected the face, that is going to be as my selected entities, and then I can change the mesh size. So I'm going to use a mesh control of 36 millimeters here. When I created that, I'm going to remesh my model to see if that resolves it. So I'm going to use the same mesh again. And as you can see, all my parts have a mesh this time, and the error is gone. Next, we will look into is the unstable model or unexpected large displacement message. And this can show up in different kind of ways, depending on what solver you're using. But the way to troubleshoot it is more or less the same with either. So I'm going to go back to use this one again. Now that the mesh is okay, I am going to try to run it. And as expected, I get a model is unstable. Check that you have applied adequate fixtures to stabilize. So here I get some information. I also get some tips on what I can do. So when I click OK to this, the solver is terminated. First thing I'm going to do to troubleshoot this is to put on something called soft springs. This puts some springs all around the model to help stabilize it and hopefully let me run through the study. Put it on. Then I'm going to try to rerun it. And this time I get another message. I get a extensive displacement message. And if you get this without expecting any large displacement, it is often a clue that something is loose. So I'm going to click no to run through the simulation, and then I can, in this case, it's pretty clear which part it is. Otherwise, sometimes you can animate, sorry, to see more clearly the movement that is happening and is unexpected. So there are some ways you can troubleshoot this even before running the simulation. You can use the interaction viewer or find under constrained bodies. So we're going to go through those tools as well. I'm going to start with interaction viewer and calculate. Here I can see the connections that I have in my model, and I can see again that this one does not have anything. I can also click through the list to see all the other interactions that are there and what they are between, what kind of interaction they are. To show that find under constrained body tools, I'm going to have to turn off the soft springs again, because this is not going to be able to run with soft springs activated. So to do that, right click the model again, go to properties, and then turn off soft springs. So I'm going to calculate under constrained bodies. And when that is finished, I get a list of the bodies that are not constrained. If I click them, they're going to be highlighted. And I can also click the direction to get an animation of where it's moving. And as I can see here, it's able to move in all directions. So now I have truly verified that this is the part that is loose. I need to fix it. To do that, I am going to apply a local interaction. And just to make it simple, I'm going to use a bonded interaction. In this case, it's loose because there's a gasket that's been ignored in the simulation. And I'm using that tips from last time, right-clicking to change box and save it. So now I hopefully fixed it. I am going to run that find under constrained body tool again, just to verify that it is fixed in all directions. And as you can see, I get the message that the model is fully constrained. So as I mentioned, you can do this before running the simulation as well, if you are uncertain if you have fixed everything. Now I'm going to run it again, and as you can see, there is no error message, and I get some results, which is good. I just want to mention one thing before we move on. If you use the soft springs when troubleshooting, make sure to always turn them off again before running the final simulation. Otherwise, you might get incorrect results because of this extra stiffness that is applied to the model. So we have looked at 2 common error messages. I hope this is helpful for you so that you can troubleshoot on your own next time you see them. I think Eirin has a question for you now.
Yes, so once again, we would like to know a little bit more about you. So how experienced are you with SOLIDWORKS simulation? So are you a beginner, or you're already an advanced user, or you feel that you are expert? Okay, let's wait a little bit more. 90% of people already voted.
Good.
And let's check the results. Yeah, so basically half of attendees are beginners and 40% are advanced.
So a bit of everything then. That's good. Good that we reach out to all. Okay. So next thing we're going to look into today is stress singularities. Here we're going to start a bit about what stress singularities are and why we get them. Then we're going to look into a tool to verify this. And then we're going to look at a few actions that can be taken when we have verified that that is what we have. So when we do simulations, we always need to make sure that we have converged results so that the stresses are as close to real stresses as possible, and it's not mesh dependent. So the way we make this convergence test is to refine the mesh and to see that the stresses converge. But sometimes, especially around sharp edges or point loads or that kind of things, we're going to experience diverging stresses. And that is what stress singularities are. They are causing this because they have no finite answer. A simple way to look at this is to look at that stresses is equal to the force divided by the area. So when the area goes towards 0, those stresses are going to go toward infinite. So to illustrate a way to find and make sure that this is what we have, I'm going to use this simple L bracket. I'm just going to set up a quick and simple study on it. I'm going to have a fixture on top. And then I'm going to apply a load to this face, and I'm going to have it pull downwards. And that's going to have a magnitude of 900 newtons, and I'm going to make sure that it goes downwards. Okay. Since I know that I am going to get high stresses on that edge in the middle, I am going to apply a mesh control to this. I'm just going to use the default parameters for that mesh control. And then I'm going to create the mesh, and I'm going to use the default for that one as well. You can see it's a bit refined in that edge, but not too much. Then I'm going to go ahead and run this study. And as you can see, my higher stresses are in that edge, but I still don't know if it's singularities or a stress concentration. So now I could either troubleshoot that manually by refining the mesh and see how the stresses converges or diverges. But to make that a bit simpler, I am going to use a tool called Stress Hotspot Diagnostics. So when I do that, I'm going to run that, and then I get a message that, yeah, you have higher stresses in an area that is commonly could be a stress hotspot place. So when I'm done running it, I can look at the stress plot. I can also isolate the areas that are of concern and show all the stresses at the same time. Next I'm going to do is now I can have SOLIDWORKS refine the mesh for me to see if it converges or diverges. So I'm going to do that 3 times. I'm going to run the stress singularity diagnostics. So as mentioned, while this is running, it is refining the mesh 3 times to see how the stresses act. So it takes a little time because it's solving the simulation 3 times. Once that is done, I get the result, and as expected, I have stress singularities here. I have diverging stresses instead of converging. So now I can click the help page, and I just want to show you that SOLIDWORKS has a quite good help page where you can get information about what they are and some ways that you can troubleshoot them as well. This is available for almost all functionality in SOLIDWORKS, and it does have a lot of good input. When I am done, I can again isolate the areas, look at the plot, and I can also get out a graph of the convergence to see how the stresses increase with the refinement level. When I click OK to this, I get a plot in my list that includes the stress singularity, where I can see what the maximum stresses are outside of that area, and I get that area highlighted in gray. So I do recommend use Stress Hotspot Diagnostics tool if you are concerned that you could have stress singularities in your model. So now that we have it, what can we do? Well, one thing is just to include that plot in the report and then kind of explain the cause and provide some valid results for those surrounding areas. Another thing that can be used and is a good approach, especially in this kind of situation, is to apply Phillips to the area. So we're going to go back into the model, and I'm going to have a study. I'm going to have the same boundary conditions, same setup. So instead of creating it all from scratch again, I am going to copy I'm going to copy that existing study. I'm going to give it a better name. I'm going to call it with Phillips. And then I'm going to change it to be used on the Phillips configuration that I already have in my model. This is grayed out now, and that is because that is not the active configuration. But if I right click, I can activate, and then everything will be available. I do get an error here, and that is because that mesh control I created, that edge is no longer available. So I need to change that, and I want to have a mesh control on the Phillips instead. I'm going to use the same mesh. I'm just going to click S and then run that study. And our results, we can see that I still have the highest stresses in this area. So just to make sure, I'm going to run the tool again. So to activate, right-click results, go to stress hotspot diagnosis, and run. And this time, I get another message. I get that there are no stress hotspots. So my results are concentration, and it kind of makes sense based on the geometry and the boundary conditions that I have here. Okay, so now we've been looking at what stress singularities are, how we can verify them, and a few actions that we can take with them. Okay, I think Eirin has another question for you.
Yes, and will these tips improve your ways of working? So yeah, today tips and tricks was amazing, and I hope you saw the first part of tips and tricks. If not, please check our webpage where you can find the recording, or go to YouTube channel, PLM Group YouTube channel, and there you will find the first part of tips and tricks. Okay, let's check the results. So 2/3 of participants are thinking yes, that they will improve the way of their working, and 1/3 is not sure.
Okay, I'm glad that a lot of you find it helpful, and I hope that you that are still a bit unsure will find it helpful too. Okay, so last thing we're going to look at today is some tips regarding results visualization. So we're going to look at 3 tips that can be used for this. And we're going to start by looking at something called superimposed deformed shape. So here I have a model where my study is run, everything is ready. And to visualize the deformation, I can animate the plot. This gives a clear view using video, but if I want to have it more visually displayed in the plot by itself, I can go into the chart settings and activate the superimposed model on the deformed shape. This gives me an original shape that I can have as transparent as I want. I can also animate this again to have it more visually, see how it moves from that original shape to the deformed shape. When I animate, I can use this back and forth that I am using, but you can also have it just go once or loop. But I prefer the back and forth because I think that is a good way to present it. The next we're going to look at is showing simulation results on one part in an assembly. So sometimes it can be really nice to just show one part. Here there are no options for this now. So to activate this possibility, you need to do the simulation study from the assembly. But I'm just going to do it in one part, so I'm going to suppress all the others. And then I am going to create a study on this one. So I'm just going to apply material, add some fixtures, and then add some loads so that I can get some results to it. And I'm going to run that. And now I have the results in a nice plot. I'm going to hide the fixture and the floors. And then I'm going to go back, and then I'm going to unsuppress the other components again so that everything is visible. And then I can see that I have an option for simulation display on the menu now that I have a study. So here I can pick which study and plot I want to use. I want the stress plots. I can have the form shape or just follows. I can show the mesh if I like. I can also include a legend, and then I can manipulate so that it is displayed as best as I want it. The brightness and the reflection. When I'm happy with this, I have a good display of the stresses on this one with the other components included. And a good tip then to have this nice linear report is to use one of the rendering tools such as PhotoView 360 or Visualize. And there you can include with the simulation results. And then you get a nice presentation for your report. Last one we're going to look at is when you're on the opposite side, where you have multiple components in a simulation, but you just want to show one or a few of the selected entities. In this case, I'm going to use that cabinet I was using for some of the tips on Tuesday as well. In this case, I want to show the stresses on the pins, so I'm going to hide that top part. So these plugs, pins, what do you want to call them? And since I already have the stress plot, I can look at the global stress for all, and I can see that my highest stress is 1.5 megapascal. I'm going to create a new stress plot to do this only on some plots. And to do that, I need to expand the advanced option, and I'm going to select show plot only on selected entities. I'm going to change that to bodies, and then I can just pick those 4 pins that I want displayed. So one good tip with this also is that if I want just the legend to show the values for these ones, I'm going under chart options and checking the box to show min-max range on shown parts only. Otherwise, it's going to be the same max. But now I can see that my maximum in the pins is approximately 0.97 megapascals. Okay, so that was the result visualization tips I had today. To sum up what we've been through, we have looked at how to troubleshoot some common error messages. We have looked at how to verify and handle stress singularities. And also we've been through some nice ways to visualize your results. If you want to learn more like tips and tricks like this, I did mention it last time, so some of you heard this before, but I have an upcoming video series on YouTube regarding tips and tricks in simulation. If there are anything you'd like to see that, I really appreciate some feedback on it. You can answer the survey after this webinar, or contact me on LinkedIn, or contact us in PLM group. If you want to learn more or you need help, you can always contact us at PLM Group Support. And we also have our own knowledge base where you can find a lot of good guides and tips on how to troubleshoot both within simulation and other parts of the software. Thank you all for joining in. I hope this has helped you, and have a nice day.
Thank you. Bye.
Thank you.